Do you know what makes oil and gas plants stand tall and safe despite housing some of the world's heaviest, tallest, and most dangerous equipments? See, as a structural engineer, these are the machines and structures you must understand before stepping into any refinery or petrochemical plants. So today, I'll break them down, what they do, and more importantly, what you need to check as a structural engineer. Hello everyone, this is Chetan Machi, and in this video we will explore the essential equipments in oil and gas plant that every structural engineer must know. We will start with what the equipment actually does in the plant and then dive into their structural engineering considerations, for example loads, supports, dynamic effects, foundation, and more other further details. So let's begin. Now, before I start for the equipment parts, let me tell you the one word called dynamics. See, when we say dynamics in structural engineering for oil and gas equipment, we mean the time dependent or fluctuating forces acting on the structure. Unlike static loads, see, these forces changes with time. For example, temperature cycling. See, equipment heats up and cools down, so it expands and contracts again and again. Similarly, pressure fluctuations. See, during operations, startup or shutdown, internal pressure goes it up and down. Vibrations like rotatory machines, fans, or wind can cause continuous shaking. See, all these repeated changes create fatigue stresses which can slowly weaken steel and cause crack if not designed properly. So, whenever you see the word dynamics in structural consideration, remember it means the structure is facing changing loads over time, not just steady ones. So let's begin our segment with the first equipment, which is the distillation or process column. They are also known as fractionation towers. So what they are? Basically, they are tall vertical vessels used to separate crude or chemical mixtures into fractions by heating and condensations. Why they are important? See, they are common in every refinery or petrochemical unit. They are very tall and slender. Let's talk about the structural consideration that you have to keep in mind. Obviously, the load part like dead weight, liquid hold up, wind, seismic, thermal expansion. They usually support on skirt or legs on the concrete or pile foundation. In case of offshore, they are the deck mounted with bracings. Here, the dynamics are they are slender, prone to vortex shedding and resonance. Commonly used material are carbon steel with corrosion allowance. And for the excess part, they are usually with the platform, ladders or modular erections. Second, reactors. So basically they are vessels where controlled chemical reactions occur under high temperature and pressure. See, they are very heavy, thick-walled equipment with significant heat and pressure cycles. What you need to take care in the structural consideration. So let's understand this. See, in terms of load, they are heavy concentrated loads from shell plus catalyst plus processed fluids. They are supported on large foundations which are designed to limit settlements and often deep piles. In case of their dynamics, here there is a temperature cycling and pressure fluctuation cause fatigue. Commonly used material segment is alloy steel for high pressure and temperature, and in case of excess, in that case large lifting clearance needed during their installation. Third, heat exchangers and air fin coolers. Basically, they are the equipment that transfers heat between two fluids. Air fin coolers specifically use airflow for cooling. See, basically, they are everywhere in the refining and petrochemicals, mounted both horizontally and elevated too. In their structural consideration, obviously you have to take care for the loads, vertical loads from shell and fluid plus wind loads if elevated. In terms of support, horizontal exchangers are on saddles and air fin coolers are elevated on steel frames. In their dynamics, usually a fan vibration is critical in air fin coolers. They are made up segment of the carbon steel with stainless steel in corrosion surfaces. And in case of excess, They require maintenance platform for tube cleaning. On number 4, we have horizontal and vertical vessels. Basically, they are cylindrical pressure retaining vessels oriented horizontally or vertically. Why they are important? See, to store or process fluid under high pressure, where they are very common. See, in that case of structural consideration, you just need to keep in mind the internal pressure, dead weight, wind and seismic loads. Usually they are supported horizontally on saddles, and for the vertical part they are supported on skirt or leg supports on steel frame. In case of their dynamics, vertical vessels prone to overturning, horizontal vessels induce localized loads on beams. Usually they are made up of steel with corrosion allowance, and in case of their access, the platform and ladders are provided for the operation and maintenance purpose. On number 5, we have cold box. See, it is tall insulated box housing cryogenic equipment for gas separation or liquefaction. See, they are essential in LNG and petrochemical units. For their structural consideration, obviously the loads, heavy equipment inside plus their insulation weight. Usually they are supported on tall steel structure with bracing and strong foundations. In case of their dynamics, we have to take care for the wind and seismic effects, which are significant due to their slenderness, and they are made up of cryogenic compatible steels. For the access part, sealed insulation means careful design for any entry points. On number 6, we have reformer. See, it's a large fired heater reactor used for hydrocarbon reforming in refining or petrochemicals. They are critical unit with extremely high thermal loads. In case of their structural consideration, these are the high loads in self-weight plus refractory lining loads. Apart from them, whatever the design loads we require that we need, like wind, seismic, dead load plus live load considerations. In case of their supports, they are massively support on massive concrete foundation. Expansion joint are required in their case. In case of their dynamics, they are the thermal cycling induced stresses. And for the materials, usually alloy steels with fireproof structure is required. And in that case as well, for the excess part, major clearance required for the tube replacement. On number 7, we have pressure vessels. So what they are? Basically, they are cylindrical vessels designed to hold fluids under high pressure. See, they are common in oil refining and chemical processing plant. Now let's understand the structural consideration. See, in every part, loads are the common point that we need to take care, but here I am still repeating the common or the differentiation in loads. Here in loads, we have internal pressure plus weights. They are usually supported on saddles, skirts or legs depending upon their orientation. In case of their dynamics, they are usually with the cyclic pressure and fatigue. Here in the material part, they are made up of high strength steel with corrosion allowance, and for their access, clearance is required for inspection and hydro testing. On number 8, we have storage tanks. Basically, they are large above ground cylindrical tanks for crude, refined products or chemicals. See, they are always present in refineries and terminals for the storage indication or the liquid processing unit storage purpose. In their structural consideration, we have to take care of all the category of the loads, hydrostatic pressure like wind, seismic data and the settlement criteria segment as well. They are usually supported on ring wall or raft foundations. In case of their dynamics, it's sloshing effects in earthquakes. They are made up with the material of carbon steel with corrosion protection, and for their access, usually they are provided with the floating roofs, ladders and platforms. On number 9, we have flare stacks. See, they are basically tall towers used to safely burn waste or excess gases. They are key for any plant's safety. In case of their structural consideration, common loads like dead load, wind, seismic load, all the loads are required. Basically here, wind governs the design and seismic are very important, the criteria for the design segment. They are usually supported on pile foundations, guide wires or self-support towers. In case of their dynamics, they experiences vortex shedding and vibration. In case of material, they are made up of heat resistance alloys, and for their access, usually elevators or ladders are provided for the inspection. On number 10, we have pipe rack and piping system. So basically, they are elevated structure which carries the process and utility pipelines across the plant, and they are important because they connect every unit from plant's circulatory system. So basically they run the entire plant's piping system. In case of structural consideration, we have to take care of all the equipment and piping loads apart from wind and seismic loading. Usually they are supported on the steel bands with bracing, and usually they are supported on RCC framing as well. In case of their dynamics, usually they experience the thermal expansion, sliding supports and loops, thermal anchor and friction loads, and they are made up with the structural steel and fireproofing. For their access, usually the walkways and cage ladders are provided for the inspection part. On number 11, we have compressor and pumps. Basically, they are rotating equipment used to move gases and liquids. They are essential to keep the process running. In case of their structural consideration, we have to take care all the entire segment of the equipment weights in terms of empty, operating, high rotation in terms of empty, operating and the other loads. Usually they are supported on block foundations to minimize the vibration. In case of their dynamics, vibration is the major design concern, and they are usually made up of the reinforced concrete foundation with the grout specification. For their access, space for maintenance and lifting is required. On number 12, we have cooling towers. Basically, they are structures used to cool the circulating water through evaporation. They are very critical for plant utilities. In case of structural consideration, we have to take care the water weight and wind loads apart from the dead and the other loads. Usually they are supported on heavy RCC or steel frame foundation. In case of their dynamics, the fan vibration is considered, and materials are RC, FRP or timber with the coatings. And for their access, usually walkways and ladders are provided. On number 13, we have skid and package items. Basically, they are pre-assembled module units which are delivered on steel skids. Why they are important? They speed up the construction and reduce the site work. See, in case of their segment, the structural consideration are all the concentrated skid loads on the beams that we need to consider. Usually they are supported on steel frame or deck with the stiffeners. In case of their dynamics, some includes the rotating equipment and vibration that we need to check during the design part. And for their access, they must allow crane lifting and modular installation. On number 14, we have PDC building, that is Power Distribution Center. It's a package item, prefabricated modular building which housing control and instrumentation. They are basically, in terms of electrical and instrument, they are brain of the plant. For the structural loads, all the common building loads that we need to consider like self-weight, equipment inside and the other live loads and the platform loads or piping running around we need to consider. Usually they are supported on steel frame platforms. Foundations are designed for modular liftings. In case of their dynamics, they must withstand the blast, wind and seismic loads. Usually they are made up of the prefab steel with fireproofing. For their access, usually walkways, stairs and blast resistant doors are provided. On number 15 and the last one is the control buildings and substation. So basically they are permanent RCC or steel building housing electrical and control system because they are very critical for safe and controlled electrical and instrumentation operation. The common loads that we need to consider are dead, live, any equipment like heavy transformer and switch gears loads we need to consider. Usually they are supported on RCC foundation or isolated pads. In case of their dynamics, seismic and blast resistance loads are important. Usually they are made up of RCC with the fireproofing. And for their access, they must allow safe evacuation routes. That is one of the important part. So now you can see that every single piece of equipment has unique structural demands. So it's not just about the dead load or live load. It's about wind, seismic, vibration, fatigue, thermal expansion and safety. So ignoring any one of these can lead to unsafe structures and costly failures. And that's your beginner's guide to the equipment every structural engineer must know in oil and gas plants. From towering distillation columns to critical control buildings, each comes with unique structural challenges. So if you are just starting your structural engineering journey, Remember this. Understanding the equipment is the first step to designing safe, reliable, and efficient facilities. So if you found this video helpful, hit that like button and share it with your fellow engineers. And don't forget to subscribe for more practical structural engineering insights. I'll see you in the next video. Till then, keep learning, keep sharing. So whatever equipment I have mentioned here, I have prepared one brief summary. You can check out that particular summary. The link is given in the description box. Stay tuned, keep learning and keep sharing.